Greetings for the day, and before we get into today's topic, which would be case studies on building envelope design, I'd like to just brief about what I do and what I've been doing in this space. So I've been in this energy and the green space in building design for the last decade or so, and we have worked on many projects across various types. So a little bit about that we'll see into what we'll cover today. So initially, before we go directly into the case studies, this would be the framework that we would be talking about in the next 1 hour. One would be the sustainability goals in building design. So when we look at the larger, the bird's eye view of the entire design process, envelope is one part, but how do we go about with the envelope is only when we decide on the goals of the design process itself. Only then can we fine tune and come further down into the various components of the building, of which the building envelope is one of it. Then looking at the role of envelope in the climate responsive architecture. So all of us today are talking about architecture that responds to our environment, responds to its surroundings, to the climate and so on. So what is the role of envelope in such a design process? Next would be your components of an efficient envelope. So this is coming down to exactly what we are going to be talking about, and all the case studies will cover one or all of these components that I am listing here. Again, this is not a comprehensive list. It is purely based on our experience over the last decade or so. So one would be your building plan to enhance efficient envelope. So why are we talking about a plan when we are looking at the skin of the building? All of us know when we say building envelope, we are looking at the skin of the building. So why are we talking about planning? So it's just like what we eat or what we consume is reflected on our skin. Similarly, what you plan, what you put inside the building in terms of function, shape or form or orientation would impact the envelope of the building. And landscape. So landscape is a less talked about subject as far as the building envelope is concerned, but I will also bring out some points why landscape is effective and how it really helps, especially in very hot and humid conditions. And window to wall ratio. So all of us know that the quantum of glass that's being used on the facade will play a critical role. And choice of materials, of course, how is the thermal property of each of these materials that you're going to be talking about in the skin of the building. It could be your roof, your wall, your glass, your roof skylight and so on. And last but not the least, your shading devices. How do they impact your building envelope? So we'll cover all of these through our case studies. So I've picked 3 case studies and 3 across different categories. One, as you see, is a school building, an educational building. The other being an office, corporate office building. And the third category is slightly different, which is basically, I was looking at a residential, but a residential category which is pretty much for street children. So it's called the Home for Street Children it's in Hyderabad. And why I picked these 3 categories, apart from it being in different type of buildings, why is one, the street children or the Home for Street Children project is, they wanted to go green, but they did not want to increase their budget. They wanted it as per whatever they had originally, initially estimated and planned, but nevertheless green, and nevertheless the envelope also becomes a component of green and efficient design. The last case, that is the Coal India corporate office building, is a plush building. Coal India being a public sector undertaking, has all the funds, wanted a landmark building, had enough funds for the best possible features. So I'll tell you how the envelope was dealt with in that section. And then the Ela Green School, being our very own school, we have the luxury of all the expertise, the analysis, the tools at the least cost possible. So I've picked across 3 case studies which come under 3 different categories on how we can actually address the envelope, irrespective of the fact that we have the sufficient budget or not. So when I started this whole session, I said goals in building design. So how many of us actually set sustainability goals? We all have how our building should look, or how should the shape of the building, the glass. We have so many other criteria, the kind of classrooms that we want or the kind of rooms that we want, etc. But do we think of energy efficiency? Do we look at water efficiency being the primary criteria, or do we look at usage of materials? Or do we look at a building that will allow for integration of technologies? So when I say integration of technologies, what we do today, it should be a flexible, it should be modular. Can we do something which we even don't know exists today, but will that building be able to integrate that tomorrow? How is it flexible in design? So in which case, are we looking at a whole building analysis that treats a building and a site as a complete system? This is critical because when you place a building on a site, if you look at it as just the particular site, then we are really not doing justice to the entire design process. So for that, we'll have to see what is the site surroundings, how does it impact our site, how does it impact our building. And also, do we also look at the building and its various components of the building as the interactions between all of these components as one whole. So one is the MEP, the mechanical person may be designing, the architect will be coming out with a beautiful design, the structural person will be coming out with various designs. So how do we look at it as one whole and see the interactions between all of these components? What is the landscape consultant going to add value? So if we don't look at it together as one large picture, as we call it as the integrated design approach today, we are probably not doing the best justice to that project. And also, are we going to look at providing opportunities for learning? Is this building going to be serving as a textbook for other people? Is it an educational building, or is it a building where it's going to have many visitors from different countries? So do you want it to be physically or visually looking like something that people can learn from it immediately? And are we looking at net zero? Are we looking at energy as a critical focus? How much of, if not net zero, if we do not have the budget for that, what are we looking as in terms of offsetting, in terms of renewable energy? And critically, what are we doing? Are we trying to not only just look at various elements in terms of enhancing the performance, but what would be the most critical component is how do we minimize our first cost? So although we are looking at a payback, etc., but how can we do that? Can we do that at all? If you're talking green, does it necessarily have to mean that you're actually spending more? We'll see as we move in through the case studies. So what is critical here is the goals we set define our design process and in turn our output, and output here being the complete building. So all of us do know that climate dictates a lot of our parameters of life, the way we dress, the way we clothe, our buildings, the way they are designed. So in terms of food, in terms of festivals, in terms of colors. So obviously architecture also becomes a very integral part of what the climate has influenced over many years. So all of us do know that ancient architecture or traditional forms of architecture were basically a dynamic synthesis of your environmental, your cultural and your social factors. So the critical component is we are not talking anything new. When we talk about envelope design or when we are talking about green building focus, etc., we are not talking anything new. We are only trying to see how do we actually bring in all these factors that once influenced our design process. Of course, today we face a lot of constraints in that process, and how do we overcome that? So if you see, many features in architectural design per se are a functional response to our climatic conditions. So I just wanted to take one example. If you see the lattice screens, and these are across the globe. So you can see it in Jaipur, you can see it in Jeddah, you can see it in Cairo, you can see it in Tunisia. In all of these, they had a specific purpose. They were derived because, how do we cut out or intercept the direct solar radiation or the direct heat that's going to fall on the building, and also to soften the uncomfortable glare. So we don't want large openings where there's going to be a lot of glare, so screens. So they basically, instead of having what we have today, screens inside our glass, these were architectural features. And also, it also served as an element to provide privacy. So this becomes again a cultural, a social factor and the aesthetic value. So in one country they use wooden lattice screens, in the other it was stone. So that depends from country to country. Similarly, those kind of concepts are being incorporated in today's modern architecture. So it need not necessarily look like what it looked, but it would have the same functional value. So this is where we are trying to say, let's try and bridge what we are trying to achieve through the green building design process in terms of the principles of traditional architecture. So this is one of, so just to take an example, the Golconda Fort, we were told that the thickness of the walls is something like 17 feet and in some places even 34 feet. So this was primarily done for various reasons. Being a fort, it probably was a safety security reason as well. But also if you just step into the Golconda Fort, you will realize the temperature difference. You will feel much cooler inside. Of course, today we do not have that kind of luxury of space, or we do not have that kind of budget and time frames. In today's modern technology, we are building 3 floors in one day in the more developed parts of the world. So how do we still achieve the same temperature differential in today's technology of, let's say, precast, let's say modular? There are so many things that is available today. And how do we apply these climate responsive design measures in our today's buildings? So when we say climate responsive measures, what all do we come under? One is sun, obviously the sun path analysis. So if you actually can see those images on the slides right now, that's one of the analysis that we have done to just analyze the shading. At what time in the day, at what part of the year is the building going to be maximum shaded, and how do we position it, how do we orient it according to the sun analysis, and which will give us the optimal results. So just by placing your building right, you would have done a whole load of good in terms of direct heat falling on the building. And then in terms of wind, so if it's critically this would be an important component if it's a non-air conditioned building. So how do you utilize your wind direction, how do you position your openings, how do you channelize wind? Temperature, so what is the kind of temperature of that region, and how are we going to address it? Relative humidity becomes critical mostly in coastal areas where you have your humidity levels are very high, and this is where most of your passive measures really don't work, because your discomfort predominantly comes from humidity, not so much the temperature. And we're looking at microclimate. What is microclimate? It's nothing but your site specific climatic conditions. So you may be in Chennai, but your site may be located near a forest or near a park space, or your temperatures may be lower, or there may be a water body. How do we actually study that specific site or that microclimate of that site to enhance your design process? So the first and foremost component of the building that needs to respond to the climate is your building envelope. So when it's hot outside, the first thing that you find it uncomfortable is your skin impact, you're sweating, you're uncomfortable, it's burning. So all of the impact of climatic conditions is first felt on the building envelope, and that is why it becomes a very critical component for us to look into in our design process. So this is just a chart to show how critical is the building envelope to us. So when we look at the heat gain into a building, I'm sure all of us know that the maximum amount of heat comes into a building through glass. So this is just a high-rise building that we have taken out of various case studies that we have done. It's not a hard and fast rule, but we all know that more than 50% heat gain comes in from glass. And next would be a wall. So wall is again, it depends if it's a high-rise building, it's wall. If it's a flat structure, it could be roof. So wall versus roof would be your second important. When you see that green component which says internal heat gains, it's nothing but your lighting, your equipment, your computers, etc. And that is something that we do not have much scope to play around with. So where we can actually make a difference is in terms of your glass, in terms of your wall and roof, or if you have a roof skylight. So now that I spoke about how the envelope is critical, let's just kind of break it down into various components that impact the design of the envelope. So one I said is the building plan. So until you plan your building, which could be your function, your form or shape and your orientation, all of this will have a direct impact on your building envelope. The second most critical thing is your window to wall ratio. How much of glass do we actually think this building requires? So if you are saying my building needs to look like a building from the west, it has to look beautiful, it has to have glass, then how do we design it? How do we make sure that we still have glass, but at the same time we try and minimize the direct heat gain? Landscape, how does landscape actually help in the facade of the building or the building envelope? Shading devices, your choice of materials. So, this is what, based on our experience, we have just kind of broken it down and put into various parameters, and we will talk about it. So, every building not necessarily will have all of these components, but as I will show you in the further slides, how some of these components have come to play an important role. So, the first project would be our orphanage or the home for street children, and the owner being Auxilium Navajivana. It is a Salesian Sisters group, and we have been the architects, Ela Green Building and Infrastructure Consultants. It is not a very large building, about 20,000 square feet, ground plus one structure, and location is Hyderabad. So, all of us do know Hyderabad is relatively pleasant throughout the year. Maximum summer your temperatures can go even up to 47, 48 degrees. So, but summer lasts critically for a period of 2 to 3 months. So, again, as I told you, this is an orphanage building and we had absolutely no budget to play along. So, what we have to do is make sure that our plan and form and shape can actually be, this requires no additional cost. So, we made sure that the building faces the north, the majority facade of the building faces the north, because from the north you have maximum daylight and at the same time minimum direct heat gain. And why is that? It is just common sense. Sun rises in the east, sets in the west, so direct harsh rays are more likely to fall on the east. Of course, we do have a lot of analysis tools that are available to us to do the study. I will talk about them as well as we talk in our case study. And if you see also the dormitory spaces, so that is the space where most of the children are going to be spending most of their evening hours. But morning hours, there are a lot of learning spaces that are also there. There are language spaces, there are the homework rooms, etc. So, all of them is what would be critical, because that would be during the day, and that is when your direct heat is going to be hitting on the building. So, how do we place those spaces in such a fashion that it is one of the most comfortable locations of a building? So, when I say functionally placing certain spaces, let me just take an example of, let us say, academic building. We have an auditorium, we have classroom spaces, for example. An auditorium ideally does not require windows, because you will have to you will have to make sure that the audience focus on the stage, you will have its own set of lightings and etc. So, you really do not need to place an auditorium at the periphery of the building. Whereas, if you are looking at classrooms, you need to make sure that students or children have access to views, have access to daylight. So, how do you position this inside your building such that there is a maximum, there is a benefit because of functional spaces that you have allocated in your building. So, similarly in this orphanage we made sure that the evening time spaces are okay, it is fine, we can locate them where you do not need maximum daylight, and so most of the evening time spaces would be in the central part, and of course east and west were masked by toilets and your core areas, your service areas. And if you see also the depth of the floor plate, we did not increase the depth of the floor plate too much, especially for the critical spaces, so that there is enough daylight. And why? There is a science behind this. Daylight does not penetrate beyond a certain depth, and we calculated all of that just to make you understand. If you see the width of the window as x and the height of the window from the ground level as y, your depth of penetration of daylight is maximum 2y, giving a distance of 1 feet on either side of the window. So, when you see this is all that your daylight can penetrate. So, during the daytime we do not want children using artificial lighting, one, to minimize energy, and also there would be no need to do so. So, if you see the depth of the floor plate has been designed accordingly. The corridor spaces, if you actually see this area, all the corridor spaces were comfortably designed. So, there is enough shading for these classrooms and dormitory spaces before the direct heat hits the building. So, and even on this facade we had a lot of shading elements that I will show you in the photographs, and all this was also taken into account after studying the wind direction as well. So, this is a typical floor plan. If you see the first floor, we have the small children dorm, which is here and here. Then we have the guest room. So, the guest room, if you see, does not have access to maximum daylight, or it's why? Because it's not going to be occupied mostly during the day. And you have children's study hall here, the big children dorm over here. So, most of these spaces are well spaced out with access to, so there is only one point where they can enter the building, also keeping in account your safety and security as well. So, this is what, when I said we do our energy analysis and fix the best possible orientation. So, we use the IES software. There are various softwares available today which can help you, assist you to take the best possible decisions at the least cost possible. So, when I say how this can happen is when you are creating a simulated model, you are creating a base case which is basically based on international or Indian standards. So, if your building has to perform efficiently as per a standard design, you have for the building that you have designed, you will get a certain energy consumption, let us say X kilowatt hours. You run it through an energy simulation exercise for the parameters that you want to do. Let us say you do not want to spend so much on glass. Let us say you want to use roof insulation, or you do not want to use. So, then you will actually add these parameters into your design model and see if I do use a roof insulation, let us say which is costing me 5 lakhs, my energy savings is 1%. But let us say I do shading devices which is costing me say 7-8 lakhs, but my energy savings is to the tune of 16%, then you would rather spend that money on using shading devices rather than roof insulation. So, these are certain things that we can play around at the design stage to achieve the best optimal solution. So, here again the glazing elements, the entire large components of glass that we have planned comes in the north and the south. So, the north having a lot of shading elements, and the east and west facades are kept to a minimum, and as well you kind of block it with toilets. So, this is some of the construction. So, in terms of usage of materials, we did not want to use regular brick because we had opted for fly ash bricks, because the thermal properties of these bricks are much better than regular bricks. So, regular brick could be anything around 1 watts per square meter Kelvin, whereas the U value of fly ash bricks is about 0.72 watts per square meter Kelvin. Now, when I say the U value, what does it mean? It just means it is a measure of heat gain through conduction. So, when I say 1 or my U value is 1, 2 or 3, the higher basically the U value, the higher the U value, the more heat gain happens into the building. The lower the U value, the lesser the heat gain. So, conduction is nothing but heat travelling from a warmer space into a cooler space. So, the lower the U value, lesser is the heat transfer. Similarly, if you see, if you look at this portion, we already have corridors. The corridor spaces have grills, plus an additional shading device also was provided. That is because if you see, these windows are the south facade windows, which bring in most of the daylight. These windows that are on the north facade also bring in daylight, but only to a certain extent, because you are trying to bring in a lot of shading as well. So, what did we achieve at the end of the day? So, this being an orphanage, they did have some sponsorship for solar energy. So, the savings that the solar energy brought in was 25.5%, and the energy savings without solar was 19.7%, and spaces that were daylit was 76%, and spaces with access to views were 100%. So, this is what we had achieved by the envelope design only by basic planning, orientation, form and usage of fly ash bricks. So, we could achieve a temperature differential of 3 to 4 degrees between the outside and the inside, and this is a LEED Silver certified building.